The electric field in a region is given by E equal to E0 x I cap divided by L. Find the charge contained inside a cuboidal volume bounded by the surfaces x equal to 0, x equal to a, y equal to 0, y equal to a, z equal to 0, z equal to a. Take E0 equal to 5 into 10 to the power minus 3 Newton per Coulomb, L equal to 2 centimeter and A equal to 1 centimeter. So here we have to find out the electric field on left face. It is directed along x-axis, so only we will consider this face and this face. So E left will be equal to E0 times, at this point value of x is 0, so it will be 0, and n cap is in this direction. So if we find flux in the left face, so it will be 0. Now consider this right face. Here E right, it will be E0 times x. Till here this distance is a, so E0a divided by L, and the area of the face, this face, will be equal to a square, and theta between electric field and n cap means area vector is 0 degree. So if we calculate phi on right face, so it will be ER times a square. Now we put the values. So ER, that is E0 is this much, 5 into 10 to the power minus 3 times A. A is 1 centimeter. So it is 0.01 divided by L. L is 2 centimeter, 0.02 times area of the face A square, that is 0.01 square. Now, if we calculate it, so this will become 0.25 Newton meter square per Coulomb. So total flux will be phi r minus phi l, and that will remain this much. So we can say flux will be equal to 0.25 Newton meter square per Coulomb. Now we have to find out charge. So we know from Gauss law that phi equal to Q upon epsilon naught. So Q will be phi times epsilon naught. So phi is this much, 0.25 into epsilon naught is 8.85 into 10 to the power minus 12. So this will become 2.2 into 10 to the power minus 12 Coulomb, which is our answer. Now let's consider next question. A charge Q is placed at the center of a cube. Find the flux of the electric field through the 6 surfaces of the cube. So we know that total flux phi is equal to charge contained divided by epsilon naught, and there are 6 faces. So each face will have 1/6 of this flux. So each face will have flux equal to 1/6 Q upon epsilon. Now let's go to next question. Next question says a point charge Q is placed at a distance a/2 above the center of a square surface of side A. Find the electric flux through this square surface. So this is square surface, and at distance a/2 from its center, charge Q is placed. Now we have to find out the flux through this surface. So for this purpose, we construct a cube of side A, and then charge will lie at the center of the cube, which is completely enclosed. And we know that total flux for charge enclosed inside any closed body will be phi E equal to Q upon epsilon naught. Here in our question, only one phase is to be considered. So flux phi through the square surface given here, through the square surface, will be equal to 1 by 6 of total electric flux, i.e., that is Q by 6 epsilon naught, which is our answer. Thank you for watching.